All right, welcome viewers. All the phones should be away. We're about to do a review. Okay, we are going to do a quick review of some problems on the worksheet that I've attached. I will attach the worksheet for our Unit 8 test that's on polygons this next class. So I'm gonna go ahead and start. The first lesson from this unit was finding the sum of all the interior angles of a polygon. And it depends on the number of sides that the polygon has. That determines the sum for that particular polygon. And you need to know, you need to be able to classify the polygons based on their number of sides. So you need to know that a hexagon has 6 sides. So if I say pentagon, you need to know a pentagon has 5 sides. So a hexagon has 6 sides. To find the sum of the measures of all the interior angles in a hexagon, it's the number of sides minus 2, which that gives you the number of triangles inside the hexagon. Each triangle has 180 degrees, so it's 6 minus 2, and then times 180, so that's 720 degrees. Now, it's not on here, but let's say you were asked, is everybody listening? Let's say you were asked to find the measure of one of those angles, and it was a regular hexagon, meaning all those 6 interior angles are the same measure, and you need to know the measure of one of them. What would you do?
Divide the sum of them by the number of sides.
Exactly. So whatever the sum is for whatever the polygon, if you need to find the measure of just one of those angles, you take the sum and you divide by how many angles there are. Are we good? You're going to have to do that. And if you want to review that, you can go to the formative assessment video that's inside the same playlist for Unit 8 and watch me do one of those problems. I'll show you quickly number 2 here too. So when you get a polygon that has no name, like a 16-sided polygon, they just call it a 16gon. So they just tell you the number of sides in the name. All right, we're moving on to number 7. It's not on this sheet here. Okay. So number 7 says, what is the measure of one exterior angle in an octagon? Okay, an octagon has how many sides? 8. Like an octopus has 8 legs. Octo. Octo means 8. So I've got an octagon drawn here. Exterior angles. We draw those. I know some of you guys can't see this because it's a weird angle. To find the sum of the exterior angles in any polygon, you don't need to go through all that jazz that we did to find the sum of the measures of the interior angles, because that sum is not dependent on the number of sides the polygon has. It's always 360. So you need to figure out the measure of just one of those angles, and they're all the same because it's a regular octagon. Then you just take the sum, which is 360, and divide by 8. Are we good? You're going to have to do that too. So if you have to find the measure of one interior angle in a regular polygon, you find the sum first, and then you divide by how many sides. If you have to find the measure of one exterior angle, it's 360 divided by the number of sides. Are we good? Gotta do both of those things. All right, moving on. Number 8. Number 8, number 10. Find the value of the variable in the parallelogram. They tell you this is a parallelogram. Okay? Because it's a parallelogram, we know that these diagonals have been bisected. They're not the same length, but we know that each of them have been bisected. So 8 should equal n minus 3. And m should equal 10. Are we good? I think you can solve those equations. Okay. Number 10, again, they told us it's a parallelogram, so we know that the opposite angles are equal. So we can set b plus 16 equal to 103. Good? Consecutive angles in a parallelogram, right next to each other, those are supplementary. Okay. Supplementary means what?
On the same line.
They are. They would form a straight line, right? If we were two angles that are a linear pair, here, there we go, like that, do form 180 degrees, a straight line. So that means they are supplementary, means they add up to 180. Perfect. Okay, you guys are doing great today. Number 11. Find the value of x. All right, these red triangles right here tell you that those two lines are parallel. These marks right here tell you that those legs, or sides, because we don't know their legs yet, we don't know a trapezoid yet, are congruent through the same measure. So we have one set of parallel sides. And we've got two congruent sides here. It's an isosceles trapezoid. If you were to extend these sides down to a point, that would form an isosceles triangle. And all the same properties apply. The base angles make the sides congruent. Good, so if that's 50 degrees, that one's 50 degrees. And these consecutive angles would be supplementary, and of course all four of them would have to add up to 360. We good? Number 17, 18, 19. Where we at? All right, so they ask you to give the most specific name for the quadrilateral. We could say, yes, it's a parallelogram, okay? But more specifically, it's a rectangle because we're told that we are given 4 right angles. We can't say it's a square because we're not told anything about the lengths of the sides being congruent. Rectangle. 18. So we've got base angles that are the same measure, which means these sides are the same measure, which means it might be an isosceles trapezoid, but let's just check one more thing and make sure that the consecutive angles are supplementary, and they are. 74 plus 106 adds up to 180. That means these lines are parallel. So it's an isosceles trapezoid. Let me scroll so you can see that. And the last one, you might think, okay, yeah, it's a parallelogram. But notice that this 50 is across from 51. So the opposite sides are not congruent. It's the consecutive sides that are congruent. Two pairs of consecutive sides are congruent. That makes it a kite. I think that's mostly what I wanted to discuss with you guys. I wanted to talk to you about, though, a kite. One more concept, and I drew something up here. So everybody's eyes up here. Eyes on me. All eyes on me. Okay. So these diagonals in a kite are perpendicular, but they are not bisected, right? This is not a parallelogram. This one, however, the one that connects the two angles that are the same, that are congruent, that diagonal is bisected. So if the measure of this part, this segment is 10, the measure of this one is also 10. I think that is it. Let me just check one more slide to make sure. Rhombus. I drew this rhombus as well. All the sides are congruent, which makes the diagonals perpendicular. Same thing happens in, we'll talk about that, the square in a minute. But more, what I really wanted to show you, another thing that we were being tested on, is that in a rhombus, these angles are bisected. So if you know the measure of one side of this angle, the other side is the same. Any questions? Going once, going twice. Sold. Oh.